So today we have with us Les Murray. He has a physics degree, works in high-speed data networking, and is a lifelong science lover. Les is also a NASA Solar System ambassador and an amateur astronomer hoping to bring the wonder of science and astronomy to others. So that is why he's here today to present Discover Mars. NASA Solar System ambassadors are NASA trained volunteers who do science education and get the news about current NASA missions and science and share it with folks like us. So we're so happy to have Les Murray with us today, and we're going to get started with Discover Mars. Thank you so much. And please do remember to type your questions into the chat.
Alrighty, hey guys, it's really great to be here today. And let me start sharing my screen. All right, so my name is Les Murray, as you said, and I'm a NASA Solar System ambassador. So what we are is we're NASA trained volunteers. So I never worked for NASA. You know, I'm just a volunteer who really loves science, education, and STEM. And NASA Solar System ambassadors are trained by NASA. So I would say every week, 2 weeks, they actually have a video seminar with us. And we typically get to sit with the scientists and mission managers and people like that at NASA and, you know, get the information straight from the people at NASA. And the goal is for us to share with you the wonder, the absolute wonder of what's going on with all the NASA missions. And also to help publicize some of the educational resources that are available through NASA. NASA has a huge educational program, and there are all kinds of experiments and things that you can get from the NASA educational resources, which I'll point to a few of those. And, you know, our goal is science outreach and education. So if you're out there and you have a need, please invite us out to your meetings. You can, you know, we can come out and talk about the wonder of NASA, science, space, and just hopefully get people fired up for science. So you can actually find a lot of resources about Mars Perseverance here at the mars.nasa.gov, and you can find a lot of multimedia resources about the Mars landing. And in fact, there were a number of neat little things that we'll talk about that they actually put together for the landing. Obviously, that happened a while back, but there's a lot of cool stuff there. So I encourage you to go out there, and the link is right here. And I'll have this presentation available after the presentation. So the Mars Perseverance lander is the latest rover that went to Mars, and it launched on July the 30th, and it landed on February the 18th. So it took off July, you know, about 11 months ago, and it landed in February the 18th at about 1:15. It was launched on an Atlas V rocket. So that's one of the larger rockets. It has a 5-meter fairing. That's like 15 feet across. So if you can imagine, you know, it's pretty big space up on top of the rocket. And that's where the Perseverance lander was. And small SUV. So it's a lot bigger than you might think just looking at it. It's, you know, if you look at a kind of a smaller SUV, probably not what we drive in Texas, but it's still getting there to the size of a car. So did we have any questions yet?
Question was, did you send a rocket to Mars? So
what?
I think you're in
Well,
the
we
middle
sure
of that.
did. All right, so we hit it right on the head. So our timing was good on that one. So, that's a pretty big rocket, and just as they've done so many times, they nailed it right on the head. And what's interesting is this is the pre-landing video. So this was what they had put together as an animation prior to the landing. So I'm going to let you guys take a look at this. And so you can see it coming in over Mars. Parachuting to the surface. Dropping the back shell. And finally dropping the sky crane, which is a rocket-powered crane that actually lowers the craft down to the ground. And the reason why they do that is because otherwise the rockets that close to the ground would kick up so much dirt and rocks that it would damage a lot of their very delicate instruments that are on the lander. So you can see, so there's a little bus that when it was coming over to Mars that it rode on. That's what this little device up here is, and then it actually drops the lander, and the lander comes in at about 10,000 miles per hour, 10,500 miles per hour, and it picks up a little bit of speed up to 12,000 miles per hour. Then it'll hit the atmosphere, and that's at what they call the entry interface. That's E time equals 0. And then about 80 seconds later, they hit peak heating in the atmosphere, and they decelerate to just above hypersonic, and then come through hypersonic. And then that's when they pop the parachute. And they're going about almost 1,000 miles per hour. So this is both the largest and one of the strongest parachutes ever made, because it has to open at 940 miles per hour. So it has to take a lot of stress, and there's like almost 2,000 pounds, 2,200 pounds or more in the lander back shell there. So the parachute will only slow it to about 350 miles per hour, and then they're going to drop the back shell. That's what protects it from heating on reentry. And then you can see it'll drop the sky crane and then the powered descent. It lowers the rover, cuts the bridles, and flies off to the side and crashes so that it doesn't damage the rover. So that's a crazy landing scheme, but as the rovers get pretty large, they have to go that route because there's just not enough atmosphere on Mars to actually stop the rover or slow it down enough for a parachute. Because as you can see, even when it cut from the parachute, it's still doing 180 to 200 miles an hour, which would really ruin your day if you landed on Mars at 200 miles per hour. So that's why they, at the last minute, have to cut loose and land it with rockets. And what's really cool about this time around is they were able to miniaturize more things, and they had more cameras available, and they were actually able to take pictures all the way down. And this is just an excerpt for the landing video. And you can actually see, so this is real, this is on Mars. You can see them popping the parachute.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 450 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
So
Perseverance has now slowed to subsonic speeds, and the heat shield has been separated.
And so they got rid of the heat shield so they could look
the radar
down.
and the camera
and now they're
to
pointing
get
radar
look
at Mars
the surface. Current
and
velocity
figuring out where
is
they are.
145 meters
they're also
per
using
second
the
at an
cameras
altitude of
to
about
locate where they are on Mars
9.5 kilometers above the surface.
and try to aim for a nice, smooth landing spot. they do have a little bit of control at this point. And this is actually when they get close to the ground.
We started our constant
I shortened it a lot.
accordion, which means we
and
are
this is
conducting
looking
the sky
off
crane,
of the actual rover.
about to conduct the sky crane
And you
maneuver.
can see in just 1 second, boom, that's when the crane
Sky
lowers
crane maneuver
it.
has started.
So this is, to me, this is just absolutely
About
crazy.
20 meters off
But
the
here
surface.
is a lander that you can see the rocket-powered sky crane, and you can see it actually lowering the rover to the ground.
Tango Delta.
And then cutting the bridle and flying
confirmed.
away.
Perseverance safely
So,
on
and
the
it's
surface
just
of
like all the
Mars,
animations.
ready to begin seeking
So
the sands
it's
of
just
past
amazing
life.
what NASA is able to do with that lander. So there's incredible technology there. And we're only able to land here because of their increase in their capabilities. So one other thing you may have spotted there was the parachute, and it looked a little bit funny. And the reason why is there's a secret message encoded in the parachute. So this is a little picture of the parachute. And if you look, so there's yellow and orange, or the more whitish colored. The white is 0, the red or orangey color is a 1. And so that's binary notation. And if you add all these up, what you get is dare, mighty things. And that's one of the slogans of the Mars team at JPL. And they have really dared mighty things. And then additionally, if you decode the information on the outside of the ring, what you get is it's the GPS coordinates of the JPL NASA building. So I'm hoping one day to get there. Every year they have a tour for the NASA Solar System ambassadors where you get to meet a lot of people, and I'm hoping one year to get out there. So any other questions that we have out there?
Here's another question for you. When will astronauts go to Mars?
Well, hopefully in the 2030s. To be honest, I have not yet seen any hard projections. I've heard anecdotally people say the 2030s, and that's going to depend a lot on how things go when we go back to the moon. Because the main reason we're going back to the moon is twofold. One is to look at the water there, because if there is significant water there, that's rocket fuel, and we need it. And then secondarily, it's one thing when you're at the International Space Station, and it's 30 minutes to get back to Earth. So if anything goes wrong on the ISS, they always have a lifeboat there. They can hop onto the lifeboat, and 30 minutes later, you're down on Earth. Well, at the moon, it's 3 days, but it still is, not too bad. But anytime you want to go to Mars, it's 7 months out. So outbound going to Mars is about 7 months. And you can only really go to Mars maybe once every 18 months. So really, pretty much, you're committed to a 2-year trip. So, our technology isn't quite good enough for, a full 2-year trip. And also, you got to throw a lot of mass at the problem. So if you think about, let's say, a crew of 3, and you have to go for 2 years, and you have to carry everything. You have to carry all of the fuel, the oxygen, the food, the water, the lander, fuel down, fuel up. That's a humongous amount of mass, which is out of the class of anything we're building right now. If you've been following Elon Musk, he clearly is gunning for that, that goal. We'll see. But the only things I've seen is the 2030s.
So what are the reasons why you can only go to Mars once every 18 months?
So think about this. I have another presentation I wish I had handy, but if you think about an orbit, and you think about the Earth's orbit and Mars's orbit, Earth rotates around the sun faster than Mars does. So as soon as you launch from Earth towards Mars, the Earth is ahead of you. And by the time you get to Mars 7 months later, Earth is way ahead of you in the orbit. So the only, efficient way to get back is you have to wait until Earth catches back up to Mars. Since it's going faster around the sun, it'll eventually, about 18 months later, catch back up. And so then you can launch to Earth and make it a few months later back to Earth and have basically a 2-year round trip.
Excellent. We also have a couple questions about your job. I think they maybe had missed your initial comment. They're asking what your job is at NASA, and are you an astronaut at NASA?
I always get that question, and no. As I said at the beginning, I don't work for NASA. I'm just a science lover who volunteers, and people out there who are very technical and sciencey oriented people. You too can volunteer to be a volunteer for NASA and do this same type of presenting. Because our whole goal is to educate people about science and NASA. So my actual job is I do high-speed data networking. I do a lot of optical design, high-speed, 10 gig and 100 gig equipment for high-speed data. And so that's basically what my job description is. So I have a day job, and NASA is just my volunteer activity. So let's talk about where it landed on Mars and why we landed there. So we know that Mars was once warmer and wetter, and if you remember, one of the things that proved it was the blueberries that they found with some of the early landers or early rovers, and but also there have been tons and tons of things that have all led to saying, one, that there was a lot more water on Mars early on, that it was there for a significant amount of time. Now it's been gone for the better part of Mars's history, but it was present for a good amount of time. And what's interesting about Gizero Crater is it is actually a crater. So it was created by a meteor coming in and hitting Mars. But during that time period when Mars was wetter, we see all the signatures that say that Gizero Crater was a lake. And up above the crater, we see a delta formation. And below the crater, we see an outgoing river. So what that means is that you had a whole system of water tributaries feeding into this crater and also out of this crater. And if you look on Earth for places where you might look for life, number one, water is obviously a important thing. One of the other things is along the north shore of this particular lake, we see a lot of calcium carbonate type formations, something like limestone. And on Earth, clearly limestone is something that preserves fossils quite well, but also it has a signature that looks a lot like it might be what we see on Earth when we take satellite images of dry lake beds in places where bacterial mats had formed and then maybe been fossilized. So we have no direct evidence that there's any life there, but what's cool is it has all the elements for life, and additionally there's this signature that which is quite interesting. And up until recently, the technology wasn't good enough to actually land it in this crater, but even since Curiosity they were able to make a much, much tighter landing window, and that's what made this this landing spot, you know, a great spot to land on. So that's why they landed in this location. So I'm very excited because as they drive toward the northern side of this crater, there's a real possibility that we might find something that might have preserved life, or you know, something like early bacterial life, because there's no thought as of yet that there could have ever been complex life. We've seen no signs anywhere of anything like that, but the possibility exists for something simple like bacterial life, and there is that signature that looks a lot like it. Any questions?
I think you just answered the question that was what type of life was on Mars if there was life. So I think that was a well answered. Nothing complex, and you are looking for still evidence of bacterial or lower level life.
That's right. So, you know, and I see this posted a lot, but, you know, there's never been direct evidence of life. The things that we have seen is these chemical signatures of calcium carbonates. We also have seen one other thing that's kind of interesting is as the seasons change, we see methane plumes, and the methane plumes have been measured by the satellites, and they've also been measured by the Curiosity rover, and, you know, kind of very localized and transient methane. And what's interesting about methane is methane can't live in the atmosphere more than a few hundred years. So the solar energy always breaks it down. So it's very interesting that seasonally we see methane, and methane is produced by some bacteria. It could be something geologic, so it doesn't have to be life. But that's another interesting signature that we want to hunt down and figure out why it's happening, and why it's happening seasonally, because we don't know of anything, you know, any geologic process that could create methane seasonally. So.
Okay, a couple of other questions. Did you want to do this first?
No, go ahead.
How are people being able to create things that are so strong? I'm not sure. I may have missed. This may have been in relation to something else. Does NASA still create technology like that? And how are people being able to create things that are so strong? I think that was related earlier, so I apologize. I missed those.
No worries.
Then what is your favorite planet and why?
Well, I don't know. I guess I would say at the moment it's Mars, because I've spent a lot of time studying it, and you know, looking at a lot of the data that comes back from the scientists. But also, you know, we're going to look at Venus in the not too distant future. It looks like there's going to be 2 missions that were just announced going to Venus, and that'll be kind of interesting as well. Because we haven't gone there in such a long time, because it's a very hellish place. There's it's about 800 degrees at the surface, hotter than, you know, pretty much you would want to set your oven on. So you know, it's quite an interesting place. But right now I would say Mars. So one of the other things that is really interesting is we were able to put a number of interesting things on the rover this time, because we were able to make it lighter and include more instruments. It's only about 300 or 400 pounds heavier than the Curiosity, but it has a lot more instrumentation on board. And one thing was the technology for a helicopter, and we actually have a helicopter on Mars. And you can see the Ingenuity helicopter there, which is a little 2-pound helicopter, which it rode underneath the rover. And a couple days after they landed, they actually looked around for a nice flat spot, and then they dropped the helicopter onto the surface of Mars, and then backed away with the rover. And then they've actually been flying that helicopter on Mars. It was really quite cool, that they were actually flying this helicopter on Mars. And you can see them, this is actually an attachment chamber on Earth where they're testing it. And that's how they, were able to learn how to fly this, really thin atmosphere. The atmosphere on Mars is only 1% of the atmosphere on Earth. So it's about 1,000 bar, that's a measurement of pressure. It's about 1,000 bar here on Earth, and it's only about a few bars on Mars. And so they had to have really big rotors, and they have two counter-rotating rotors that actually power that helicopter. And it's just a technology demonstration, so there's no science instruments on it, and it's just to figure out whether we could even do it, because there are a lot of cool places in the solar system like Titan where we would love to be able to fly around. And it weighs about 4 pounds or 2 kilograms, and it can fly about 1,000 feet away from the rover, and it actually has flown about that far away from the rover. And it can take pictures and then send them back to Perseverance. And it's really incredible technology that they've been able to do this. And you can actually see, so hopefully, I don't know if you can hear with the audio of this when I play this clip, but you can actually hear, it's a low hum, you'll hear a boo. Because the air pressure is so low on Mars, a lot of the sounds are actually lower in pitch. But if you listen hard, and in the presentation, there's actually a link. I don't know if they're able to drop that in the chat for you, but you can also look at this offline. And this is actually, you're able to hear the helicopter flying on Mars. So you can see it over there on the right-hand side of the screen, and you can see it fixing to launch. Gonna take off. Hopefully all these videos are playing good for you guys. And you'll see it fly off to the left. And hopefully you can hear it. To me, it's just amazing. So one of the other things that that the Perseverance rover has is it has a number of microphones. This one, I believe, was on the super cam up on the mast of Perseverance, and it actually recorded it as it was flying. And additionally, if you go look on the mars.nasa.gov, you can actually also see pictures that were taken by the helicopter. You can also see video that was taken from the helicopter. And so go out, take a look at that. It's really, really cool. And what's really going to be exciting is newer missions where what they'd like to do is be able to use the helicopter to scout ahead of the rover. So the rover has about a 7-foot camera. If you look, there's its camera is up here, and it's about 7 feet off the ground, so it can see a ways, but having the helicopter to scout ahead and look for interesting rocks and look for interesting things and be able to actually run independently, because the helicopter is actually solar powered, so it actually flies, then it sits there for a few days, charges up its batteries, and then they fly it again. They've flown it a number of times, and they'll continue to fly it, I assume, for a while. But at some point, the Mars Perseverance has to get on with its science mission, and since the Ingenuity was only a technology demonstration, it probably will be left behind. Additionally, it's not expected that its battery will last too long in the cold temperatures of Mars. So I don't know if there were any other questions on the helicopter or anything.
Yes, we have a few questions. To General Mars, and then I have one about rivers and things. So what gases does Mars have, and how big is the crater that you were talking about earlier?
Okay, well, actually, I'll have to look that up. I knew that at one time. I would have to look that up. I want to say it's about 20 or 30 kilometers across, but I'll have to look that up. I have another presentation that actually details that and has the size of the crater, and actually shows how they had to trim down the landing ellipse to actually get it landed inside of this crater, because the Curiosity landing ellipse was actually bigger than the whole crater, and there's some dangerous terrain inside this crater. And what was the other? Oh, the atmosphere. So the atmosphere, there's a lot less variety in the atmosphere of Mars, where we have a lot of trace gases in our atmosphere. Almost the only gas that's in the atmosphere of Mars is carbon dioxide. And the carbon dioxide is pretty much almost all the atmosphere. There's a little bit of traces of argon, I believe, but it's almost all 98, 99% carbon dioxide. And it's only, as I said, 1% of Earth's atmosphere. So there really isn't much atmosphere to speak of, although if you actually do go on that site, there's also multimedia where they've recorded the wind blowing, and you may have been able to hear it in that other clip, the wind blowing by. So they have some fairly sensitive microphones. There's two of them, I believe. One that's up on that mass cam, and then another one that's somewhere on the body of the rover. And they can actually listen to the wind, and they've actually released some audio tracks where you can actually hear the rover moving. So you can actually hear the motors running and the wheels turning as it drives across the Martian desert, which I think is a really neat element to add. So not only can you see, you can hear what's happening on Mars.
Okay, also about Mars atmosphere or conditions. How dry is Mars?
It is very dry. So let's talk about the atmosphere. There's almost no water in the atmosphere. There is water on Mars, and there's a decent amount of it, but most of it is frozen up in the ice cap. There's an ice cap up on the top of Mars, just like we have a North Pole. It also has a North Pole, and there is an ice cap up there, and a lot of it is water. A lot of it is also frozen carbon dioxide. In a little while, we'll talk more about the temperature on Mars, and it is really quite cold on Mars, and we'll talk about the weather too in just a little while, but it is quite cold. So let's talk about some of the instruments that are on here. So a new instrument that is on there is called RIMFAX. And this is really cool. If you watch the History Channel, sometimes you'll see archaeologists using ground penetrating radar or subsurface radar. And that's exactly what's on the bottom side of the rover. And they can use this ground penetrating radar to actually look at the ground underneath the rover, I think down to about 10 feet. And it can see ice, it can see water, and other things that are down there. And so this will be our first look at the substructure of Mars, because other than looking at cliff walls, we really don't have any idea what the surface of Mars and under the surface of Mars is like. So this will be a nice look there. There's also the mast cam. So that's that camera that's up at the top, and it has binocular vision. And also they've released some 3D pictures. So if you have some of those old red and blue 3D glasses, they have some 3D pictures, so you can actually get a 3D image of Mars. It's actually, the cameras are actually spaced, and you can see them right here on the mast. There's 1 and 2, and they're pretty much spaced almost like human vision. So it's designed so that to give pleasing 3D images for human beings. and for also scientists to be able to kind of get a feel, and the rover driver to get a feel of what it's like around the rover. Because you have to think, you know, it's kind of difficult and fun, I would say, to actually drive that rover around when you know, you can't really see anything but the 2D pictures of what's around you, right? It's you got to drive it. You got to drive it right the first time and do it right. So they also have a weather station, and I'll show you how to get to the weather station on Mars. It's on the internet, and you can retrieve the current weather. It lags about 2 days, but you can see every day on Mars. There's also the SuperCam, which is it's a laser micro imager, and it has a laser, and what it actually does is it actually zaps rocks and then looks at the light that is returned when it zaps the rock, and that allows it to look at chemical composition. It allows you to figure out what's inside the rock. And also there's an arm, and out on the arm are a suite of instruments. One of them is Pixel. That's an X-ray spectrometer. So it can look at really fine detail with X-rays. So it can look at the shapes of crystals and particles. It can also, there's also a microscope there that can look at the rocks in fine detail. Additionally, there's Sherlock. And Sherlock is an ultraviolet imager. I forgot I was going to add a picture in here and show you, but a lot of rocks that have crystals in them, if you actually hit them with ultraviolet light or black light, they actually fluoresce. And the color that they fluoresce tells you a lot about the minerals that are inside the rock. So Sherlock does two things. One is it does bombard them with ultraviolet, but then in addition to just looking at them, it can split the light into a spectrum and look at the chemical composition, what minerals are in a rock. And so it can find out a lot about the rocks. So, and the last one, which is a really exciting one, is MOXIE. So MOXIE is an oxygen generator, and I think it was somewhere in the neighborhood of about 40 pounds or so. But it can actually take the carbon dioxide that's in the atmosphere and use the Sabatier process, and it can turn the carbon dioxide into oxygen plus some waste products. And what's great about that is it's actually able to do, I think it was like about a half a days of oxygen in that it can generate for one person. So this is an experiment that hopefully, if we can land on Mars and we have some solar power, that we could turn the atmosphere into breathable oxygen. And even more fun is those waste products that are left over after I turn the carbon dioxide into oxygen. I can complete the process if I can get my hands on water. So then I could take some water like what I can find in the polar ice caps and some places on Mars. There are definitely places on Mars where I can find water, subsurface water. And I can turn that into rocket fuel. So I can make methane on the surface of Mars using the carbon dioxide and water and solar power. So that's really exciting, and that experiment has run and was successful. So they actually did make oxygen, and so that's really exciting, because if you're going to live on Mars for 2 years, it's really exciting if you could get your oxygen and your rocket fuel on Mars. One of the ideas that's the most prevalent right now is that we'd actually land on Mars a factory which would make methane and oxygen. So we'd have oxygen to breathe and also methane for our rockets. Then we would fill up our rocket that we landed on Mars on the surface using that factory. and then go back. So we wouldn't have to carry all the fuel that it would take to get back to Earth. We only need to take the fuel that it takes to get to Mars, and on Mars we generate our own fuel and then use that fuel to get back to Earth.
Super,
so,
that's exciting. We have another question.
Yeah, absolutely.
And I think this is really interesting. So when another rover has landed on Mars, like Perseverance and Curiosity, do the past rovers get taken off of Mars? And if not, are the rovers still taking pictures and doing studies?
So right now there are 5 rovers on Mars, and the first 3 were all solar powered. And the thing about Mars that we'll talk about in a little while is that at night it gets really cold on Mars, and that's the killer that really kills rovers. Is that their batteries? You cannot let the batteries freeze, because they typically have a liquid electrolyte, and if it freezes, it'll burst the battery and kill the rover. Additionally, most of the equipment on the rover can't tolerate getting as cold as it gets at night. So what we have to do is we have to heat the rover all night long. So that means you have to gather enough energy during the day to keep the rover warm at night so that it can last through the night. Now during the day, usually the equipment is built to tolerate daytime temps, but not nighttime. It's like the desert. You know, like if you ever go to the desert, when you're out in the desert, it's very, very, whenever the sun drops, the temperature drops really, really quick. And on Mars, it plummets. I mean, it just absolutely, rolls off a cliff and plummets to about -80 at night. So if you can imagine going to -80 below zero at night, and this is Celsius, right? So it's even colder than you think. That's what killed the first 3. Curiosity and Perseverance are still actively doing science, but the other 3 rovers, what basically happened is there was enough dust on their solar panels that eventually they just weren't able to get enough energy to still warm themselves at night and stay alive, and eventually they just couldn't make it through the night and they died. Curiosity and Perseverance, if you look at this thing back here at the back, that's an RTG, or radioisotope thermal electric generator, and there's actually plutonium in there, just like you would have in a bomb. There's not enough to be a bomb, but basically what it is there's enough there that it gets really, really hot. I want to say like 600 or 700 degrees. And the rover, what it does is uses that heat to generate electricity, and the electricity is what powers the rover. So that's why Curiosity is still running strong, and also why probably, they've both got a long, long life ahead of them. Because NASA tends to over-engineer, and I think these are going to last a long, long time.
All right, another question. Can the rover bear the temperature and other stuff, I guess other conditions? And how can you make the rover warm?
So, I haven't looked directly into the technology myself, but I would imagine we have to do this on, I have to build a lot of industrial temp equipment that has to go down to -40 degrees C, so about halfway to what they're tolerating on Mars at night. And typically what you do is you have a resistive blanket. Similar, I don't know, in the old days we had electric blankets. They're a little bit dangerous these days. You don't see them as much, but electric blankets that would actually use electrical power and generate heat, and they would use that to heat them at night, warm yourself at night on your bed. And I'm sure it's probably a very similar process where they have a thermal blanket, and that thermal blanket, they use the power from the battery to warm the internals of the rover and keep them up to temp. I'm also very sure that they're probably very well insulated inside of there, because every watt that you burn at night staying alive is a watt you can't burn during the day doing science. So I'm sure it's probably very well insulated, and they do their best not to have to burn too much power keeping the electronics warm.
There's a question also about the drone that you had mentioned earlier. How high did the drone fly?
So the highest that I'm aware of that they are going to fly is about 15 meters. So I don't think that that's in any way the limit of the helicopter itself. I think that's just a self-imposed limit as to, you know, how high they thought that they wanted to go. But once they've done all of their objectives and testing out the technology, you know, I wouldn't doubt that they'll start, you know, going further and testing higher. But I do know on the last flight that they did have a little issues as they were coming down, so they may be a little bit cautious for a while, because I know that there was kind of it was kind of wobbling right before it went into the landing mode. So, but 15 meters is about as far as it will go up, and about 1,000 meters, or 3,000 feet in distance. So about what is that, 3/5 of a mile or so away from the rover.
Okay, and if the rover has lasers and an astronaut goes out in front of the rover, which we're assuming that astronauts eventually get there as well. So if the astronaut goes in front of the rover, will the laser zap the astronaut, or no?
Well, I would imagine you wouldn't want to do that or get in front of it, because that laser is actually drilling or pitting holes into the rocks. I wouldn't say, I wouldn't go as far as to say drilling, but it is strong enough that it does actually vaporize a little bit of the rock. And in fact, let's talk about that. Right here, you should be able to hear them actually firing the laser. And this was one of the first recording of sounds on Mars. And what they were doing was they were actually firing the laser at a rock, and they actually vaporize part of the rock. And when they vaporize part of the rock, they look at it with the camera, and they can see the spectrum, or the colors of light that are emitted by the rock when it gets vaporized. And that's how they can tell what the chemistry of the rock is. And so that's really, really cool. I should think to put a spectrograph image into this presentation so you can see kind of what a spectrum looks like. But that's the one way that scientists often find out what the composition of things is they look at the spectrum, because every element has a unique spectrum when it gets vaporized. And as an example, if you look at a candle with a spectrograph, you can tell what's burning in that candle by looking at the spectrum. And that's exactly what they do with the rocks. They vaporize rocks. They turn rocks into glowing gas with the laser. It's not much rock. It's just a little bitty pinpoint, but it's enough that they can then look at the spectrum of that rock and tell what makes up that rock, what elements are in that rock. So another instrument that's on there, and you can see two links up here at the top of the page, mars.nasa.gov, Mars 2020 weather. And Mars 2020 is the name of the mission that Perseverance is the rover for. And I can't remember what MSL stands for, but that was the mission name for Curiosity. And you can see the weather at Curiosity. And day to day, you could, even if you wanted to, go in here and look at the weather. So if you look, this I happened to capture on June the 10th, so that was about 4 days ago. And that was Sol, or day 109 for Perseverance. And that's a Mars day. it seems like they should call it an Aries or something, not a Sol. But a day on Mars is called a Sol, and it's already been there. Can you believe it? 109 days. And if you look, the high temperature was -6 degrees Fahrenheit. So if you guys remember here in Texas not long ago, we got down almost to those temperatures. I can't remember if we got down all the way to -6, but that's pretty cold. And so that was the warmest temperature during the day. And on a warm day, you can actually get up to shirt sleeve-ish weather. So on some of the warmest days, you could get up to about 32 degrees Fahrenheit, right about freezing, but it doesn't last long, and that's only on the equator at high noon in summer on Mars. But you know, it was -6 degrees as a high temperature, and it was -120 degrees below zero on that day. So you can see that, oh my God, it gets really cold at night. And that's the killer for rovers, and probably for people too, right? That is awfully cold to deal with. And so that's why, you know, even though it has, quote, an atmosphere, a very thin one, you have to have a very good spacesuit on Mars to protect you from the lack of pressure, because it's only 1/100th of the Earth pressure, and the temperature, which is, you know, very, very cold. So I encourage you to go out there every few days and just take a look. It's just kind of fun comparing the temperature here and the temperature there. And actually, one thing I've done is kind of looked around to see where on the Earth it's the same temperature, you know, that they might have the same high temperature. They never have the same low temperature, but they often have the same high temperature. And it's kind of fun to make that comparison.
We have a few more questions, and I know you may still have some.
Sure.
We don't have a whole lot of time left, about 10 minutes, but I don't want to forget to ask, well, we're on weather, so what is the lowest weather ever recorded, the lowest temperature, I guess, ever recorded? And then we have an aspiring astronaut or NASA engineer, perhaps in our audience, who is in the 3rd grade and is already learning how to code. And this
that is awesome.
This youngster would like to know, this student would like to know, how can they work for NASA when they grow up?
Well, you're on a good path. So if you want to work for NASA, one of the things that I would say to you is that you really need to study all the STEM that you can. So any science, math, other courses like that you can study, or even geology or biology. All of those are disciplines which NASA employs. You also want to try to be, so if you ever wanted to be an astronaut, you need to be an amazing human and a very well-rounded individual, meaning when you look at some of the astronauts that are going to ISS, you know, they've typically done lots of hiking, mountain climbing. They usually can fly. You know, it's a lot easier to be an engineer at NASA or something like that than it is an astronaut, because the astronaut has to be the best of the best of the best. But I highly encourage you, you know, do everything you can to learn STEM, to study engineering, science, mathematics, geology, or biology. And the biggest thing is be curious your whole life. Because one of the things that gets me going in the morning is my curiosity. I am a weirdo who reads science papers for fun. So, you know, basically, I encourage you to always be curious. So here is the answer to your question about temperature. So here's the temperature ranges on Mars and on Earth. So if you look at Earth, the highest temperature ever recorded was 136 degrees Fahrenheit. Luckily, I've only experienced 115, nothing over 115, but the hottest ever on the whole planet was 136. The quote average, and that average is a lot of stuff, is 57 degrees Fahrenheit. And the coldest temperature is about 126 degrees below 0 Fahrenheit. So, you know, that's cold, but look at Mars, right? So the hottest that has ever been recorded on Mars is 86 degrees Fahrenheit. So that's actually pretty cool. I have to admit I hadn't glommed onto that, but some of the numbers I'd seen were 30 degrees, but I didn't realize there had been a recorded temperature on Mars of 86 degrees. So that's actually shirt sleeve weather, although since there's no atmosphere to speak of, you wouldn't want to be in shirt sleeves. But temperature-wise, that's something that you and I would understand here in Texas. But here is, you know, that average, that global average, ouch, is minus 81 degrees. And look at this. This is the killer, right, is the low end. And that's minus 280 degrees, 284 degrees Fahrenheit. So it's a really, really tough place at night. And the reason why is because the lack of an atmosphere. If you think about it, an atmosphere is like a blanket, right? And it holds in the heat. So during the day, the sun effectively charges the planet with thermal energy, and at night it gets emitted. Well, the atmosphere helps hold in that temperature, but since Mars doesn't have an atmosphere to speak of, the temperature drops, absolutely plummets at night. So even if you were at 86 degrees Fahrenheit during the day, I can guarantee you were probably below minus 40, 50, 60 degrees Celsius at night. So, and that's the real problem, is it really needs an atmosphere to warm it up. And it's not 100% certain, but what we believe happened to Mars is when its core stopped spinning and it lost its magnetosphere, what protects the Earth from solar radiation, then it started getting a lot of high energy radiation, which molecule by molecule, what happens is those high speed radiation from the sun hits molecules of the atmosphere and knocks them out of the atmosphere. And so what happened is over, you know, a billion years or so, molecule by molecule, the atmosphere was knocked off of Mars to the point where it is now, where there's really no atmosphere. Once it didn't have that insulating blanket, it went even faster. And, you know, you are where you are today, which is not much atmosphere and, you know, really extremes in terms of cold.
So, do you think that SpaceX will get Starship Super Heavy ready before NASA or CNSA gets their humans to Mars architectures ready? Is the race to get there first between NASA and SpaceX, or SpaceX and CNSA? Any thoughts on terraforming Mars to get to be more habitable?
Well, what I will say is, as of this moment, there's no competition between Mars and SpaceX. Clearly, Elon Musk has the desire to get there, and I think he wants to get there faster than NASA does. But anybody who's a practical person says that most likely, as soon as he has a vehicle that looks like it could do heavy lift to Mars, which you know, it's looking like he can, maybe 100 tons at a time towards Mars. That's kind of the eventual design of Starship, is to get 100 tons into low Earth orbit, get 5 tankers to refuel it, and then have a full fuel tank in orbit of Earth, and be able to, you know, go on out to Mars. And you know, basically have a cargo volume of 100 tons. Well, you know, at that point, you really can, you know, whereas NASA right now is putting really small payloads to Mars. So one of the heaviest payloads they put there is Perseverance, and Perseverance was 2,200 pounds, so 2,200 pounds. So when you talk about payloads which are 50 times as large, you know, that really starts to look interesting. And so I would expect that the first thing that happens is, as soon as SpaceX looks like they have a viable option, I expect a cost-sharing arrangement where NASA will probably start to buy, just like they buy Dragons today, to go to the space station. They likely will buy transportation to Mars. They already have purchased transportation to the moon. So SpaceX has already, with Starship, won a contract to land, you know, astronauts on the moon, and they have essentially a slightly different vehicle. So the vehicle they're building and testing right now down in South Texas is actually designed to land humans on Mars. Now, obviously, it's not anywhere near that final design, but that was kind of the goal of it. But they have a different design that is designed to take off, go into space, and never return back to the Earth. So it will have no heat shield, no protection, and is really designed only as a ferry craft that will ferry large cargoes and astronauts down to the surface of the moon and then back. So, and possibly even back and forth from low Earth orbit, who knows. But as of right now, it's only been talked about using it as a you know, vehicle to go from the Gateway, which is a new space station to go around the moon, down to the surface of the moon with lots of cargo. So, any other questions?
Thank you. We do still have questions. I know it's 4 o'clock, and we typically try to, you know, wind down at the hour mark. But is Earth on Earth day and night is 24 hours? How about Mars? Is it the same?
Oh,
or how different?
It's a little bit different, and unfortunately, it's just enough to be a pain. Here we go. So it's actually 24 hours and 37 minutes. So at first, when they first landed Curiosity, they actually tried to put everybody on Mars time. And it was just murder, because if you think about it, what happens is very quickly you're out of sync with your Earth counterparts, because if it's 24 hours and 37 minutes, then, you know, think about going to bed 30 minutes earlier every day or 30 minutes later every day and getting up 30 minutes, you know, time shifted every single day. So, you know, in a couple of days, you're an hour off from the other people living in your household, and 4 days, you're 2 hours off. And also, you're constantly having to adjust your biorhythm to that new adjustment. So it's really tough, and they still do it, but only for a short time after landing. But then after that, they go to normal work days, and they don't stay on that 24-hour and 37-minute schedule. So it's a real pain if you're trying to be a rover driver, because your schedule is always dictated by Mars. And by the way, any questions that anybody wants to ask, please throw them in the chat, even if we don't have time for them, because what I always do is I will collect them after or actually I'll ask you guys there at the library to collect them. And, I'll definitely give better and more complete answers to the questions you did ask. and it'll also answer any that we didn't have time for, so that you'll get your questions answered. And I'll make sure they have a place to link to so that you can see all those answers. And also a spot where you can link to this presentation, because there was still a lot of subjects we didn't get to, learning about Mars, like how big it is, how cold it is, what you would weigh on Mars, which you can take a look at and learn about. I also encourage you to go to mars.nasa.gov, and there's a million learning resources. And if you are virtual schooling or homeschooling, there are a ton of resources. Also, you might poke your teacher and show her all the educational resources that NASA has, because there's tons of experiments for every age, studying almost any subject in science, planets, stars, anything you can think about.
Thank you. I'm going to put one more question out to you, and then we're going to wrap up for today, and we'll keep the rest of these questions so that Mr. Murray can post some answers on his blog, and we can put those things with our, this presentation is being recorded, and it will be posted to the library's YouTube, which I had put into the chat. So we would love to have you, rewatch or share with friends. Tell us about the space stations, how many there are and who runs them, who kind of, who's responsible?
Okay, so there is one. I guess I should say two. There is one space station that is operated by called the ISS, and it's currently obviously in low Earth orbit at about 250 miles above Earth, and that's operated by a consortium of many nations on the Earth. The European Union, Russia, India, America, Canada, and many, many more nations that operate the ISS. And there's also, just recently, China put up a space station called Tiangong, or Heavenly Palace. I don't know exactly how long it'll be up, and I haven't closely followed the science that they're doing there. That might be something interesting, because one other place to learn science. But in general, most of everything I pay attention to is at the ISS, and you can on NASA TV see what's going on at the ISS most days, or NASA TV on your local channel. And currently, we're in the midst of planning to build something called the Gateway. And the Gateway is a space station that is going to be around the moon. And it's going to be in what's called a halo orbit, or a high eccentricity orbit around the moon, where one end is very far out from the moon. The other end is very close to the moon. And it's a good spot where you can do low energy pickups of people and cargo, and then take them down to the moon, jump off, and then a week or so later you can come pick them up. So the idea is that we'll build another station in lunar orbit. In theory, that's supposed to happen in a few years. The next mission to the moon is 2024, although I personally think that will slip. But then shortly after that, it's supposed to start launching the Gateway. But I think it's going to take longer than that, because I still haven't seen any firm plans on the Gateway. So I think it's going to probably take longer than that. But that's those. So there are two space stations currently, ISS and Tiangong from China, and one that's going to come online in the next few years, which is the Gateway station, which will be around the moon and operated jointly by the U.S. and its partners.
Wonderful. Thank you so much. Do you have a final? Is there anything else that you wanted to make sure that you got in today? We really appreciate your time. It's been exciting and lots of good questions. Thank you to our audience. Thank you so much, Les, for presenting.
Yeah.
Was there something else that you wanted to?
Yeah, I was going to say, you can also, I have a website where you can always pick up anything that any talks that I have, I always put all the materials here on skyambassador.com. That's my website. And also, there's contact information here that allows you to email me if you ever have questions. I'll be happy to answer them. It also actually gives me the chance to go look at stuff, interesting questions. And also, the blog is where I always put entries for each talk that I give. So you can come back to this spot, skyambassador.com, blog, and you can download the presentation you just saw, and also all the questions that were asked and answered, we'll have here.
Fabulous. Thank you so much for sharing your time with us. Les Murray will also be speaking at Plano Public Library at our Schimmelpfennig Library in August. We'll be doing solar viewing. So we invite you to come out and join us at Schimmelpfennig Library in August. That'll be on the library calendar. The library website we did put into the chat. I'm putting that back in now. We would love to have you join us for that, when you can learn a little bit more about the sun. Thank you so
and we'll
much,
have
Les.
a couple of solar telescopes so you can look through them and actually see the sun's corona and the sunspots.
Excellent. It's been a great day. Thank you so much, Les, for sharing your information and your expertise with us. Thank you all for joining us for this Plano Public Library program. We hope to see you in the library and online again soon. Y'all have a great day.